This is my work uniform on the left in 1973 when I graduated from college. I was a real-time assembly language programmer on Data General mini computers. I did that for a bunch of years and sat in labs late at night doing one-of-a-kind hardware software solution for a company called TRW. And then I started getting involved in personal computers. I built a kid computer in '74. Thought that was cool. I could have my own personal computer, and then went up the chain of Apples and Ataris and PCs and so on. I joined Borland in June of 1985, working for Philippe Kahn. I managed the compiler group in R&D for years, and then changed to do this evangelism role where I have a bunch of responsibilities inside the company as an executive, as well as I travel around the world and meet with developers and do presentations like this. Go into your company, help with design reviews, track down issues, whatever it might be. That's why I give everybody all my contact information. I can walk over to R&D in Scotts Valley and beat on somebody if there's some problem that is obscure that we're trying to figure out. And ultimately, I'm just a programmer. I love to program. I like to figure out how to work with all these new devices, as well as still do things on Windows and to build applications. Try to blog as much as I can, do as many online events, create videos and other things. So if you have things that you need shown, maybe not today, but to show how to do something, that's usually a good item for me to blog about or create a video or do an online screencast, or even just connect with you directly through Google Hangout or other mechanisms, Skype, and we can go through things that you're trying to do. Because I love to think about new ways of programming. I love what we do because it's true to what I cared about when I first was in college, and it was all about how to do more with the hardware at the hardware level, at the device level, at the interface level. And that's what we do in our products. There are many other solutions from vendors who have platforms and devices, and they'd like you to use their tools on their products, but then you're faced with having to use different tools and different languages on different products for the different platforms that you want to support. There is the web-based technologies with companies like Accelerator and Coney and all these other guys, Sencha and so on. They take a JavaScript HTML5 approach, and then they rely on having a mechanism to go from JavaScript through to the native hardware and the native APIs. And then they have to do the work because there's no standards for a vibration circuit on a device or for a camera interface on a device, or for that matter, anything else that might be on Samsung, iOS, or somebody else's device. So what we do is we just say it's all about native code. These are native processors in these devices. Android, for example, comes with two SDKs, a Java and a native SDK. Underneath, it's got hardware and it has an operating system. So I like to talk to it. I like to connect to it. I like to be able to have to write some code that can connect to all these different devices. And one of the things we've spent the last 3 and 4 years on is figuring out how we can support multiple platforms with a single set of source code. Maybe you have to do some if-thens, because some of these platforms have nice APIs that you might want to do something specific for Windows or for Macintosh or for Android. So we do that, and you can look at our code. We give you all the source code to the runtime library and to the FM application platform and to the VCL for Windows only. All the source code is there. So you can see how we do it. You can see how we drop down and do if-defs in the RTL and in the source code ourselves for all these different platforms. How to get at the cameras, how to play audio, how to play video, and so on. And then occasionally, where there's an interface that isn't native, then we show you how to get from native code into some managed code system. Through Java interface, through JNI on Android, through Objective-C Bridge on iOS and on Macintosh, if that's what we need to do to expose a Bluetooth interface or some other kind of special device. The great thing is nothing is between you and the operating system and the hardware. It's native code. It might be a static library, we give you the source code to it. So there's no JavaScript runtime, there's no Java virtual machine, there's no something else that's between you. Everything ultimately is going to be statically linked in to your application at the application level. It's an app bundle on OS 10 and iOS. It's an APK file on Android. It's an executable on Windows, whether it's 32 or 64-bit Windows. And that's how we get the one team, one code base, doing it in Delphi, and now C++. We're previewing the C++ for iOS, which will be out this month. And then the Android version will be out in the wintertime, which goes up until, I guess, the first day of spring in March. Jim McKeith, who's on my team, has taken a Delphi app, and here's the code you can see here. And just as you would see in the project manager window in the IDE, a target platform, for example, my Samsung Galaxy S4, or unfortunately my Nexus 7 2012 edition. I bought 3 2013s, but people wanted them, so I gave them to them. And here's the screenshot where he grabbed, which just said label1.txt equals hello glass from Delphi XE5, and that displayed on the Google Glass, hello glass from Delphi XE5. It's just another Android target device. There's one being used right here. It's got a touch pad on the right-hand side. You can do gestures. Just use T Gesture Manager. The same T Gesture Manager you would use on Windows 7 in Delphi 2009 or C Builder 2009. Tap, double tap, tap and hold. Those are the interactive gestures. Right, left, up, down. You have all the access to all these gestures in your own applications, as long as the system has some kind of touch-based system, or if it has a mouse-based system, we take the mouse movements and we associate those with the gestures. So if there's anything, if we haven't wrapped it, then somebody's either written a blog post or Brian Long has done a video or done a blog post to show you how to do it all at the lowest level. We had our Code Rage 8 online conference back in November. And if you really need to get at something that we don't provide a component or an RTL wrapper or a class interface for, then watch Brian Long's 2 sessions on Delphi and iOS API, Delphi and Android API. It's 45 minutes each approximately with Q&A. It'll show you everything you need to know about getting down inside the operating system. But ultimately, we will wrap everything in a component and or a class. We keep doing that in every release. A lot of times we'll just do it as examples. You can go download them from SourceForge, and there's your class wrappers, and there's your components. So if you say, well, I can't do something simple today that should be simple, then we'll show you how to do it, or we'll make it simple. That's our goal, always been our goal. That's what we did in DOS with TurboVision. That's what we did with object windows on Windows, what we did with the VCL on Windows. We've been wrapping APIs and hardware interfaces with classes and components for more than, well, since 1993, and then in DOS and Windows since the beginning of time, basically. As soon as we added objects to the language, so since Turbo Pascal 5.5 and Turbo C++ 1.0. We have a lot of years understanding this, and we're not afraid to do the hard work under the covers to help you be more productive versus other tools that might say, well, unless there's a W3C standard API for all the vibration circuits, then you have to do the custom work or find somebody that knows how to go from JavaScript to whatever that thing is. So in this device world, when we're sitting on a Windows desktop doing client server, we know how to build an application that talks to Oracle, talks to DB2, talks to some other thing that's sitting out there somewhere in our enterprise or network infrastructure, talk to databases in the cloud, and so on. When we start moving away from desktops, we have to start thinking about, number one, how do we deal with the user interface and the constraints of the device form factors? And number two, how do we get at all that data that's out there? There's many ways. Obviously, you could build a SOAP server that grabs and talks to some remote database, a web service of some kind, some remote procedure call mechanism. We have our data snap technology, which allows you to separate out database access and business logic from wherever the database is somewhere. For certain devices, they come with database. So iOS and Android have SQLite. It's an open source, lightweight. It has 4 fundamental data types, and you lock the database. It doesn't have the notion of transactions. It's not the fancy SQL 92. So imagine you need to build an iOS and Android device to talk to a Microsoft SQL Server database running in your infrastructure. Well, you go to Microsoft and you ask them, do they have a SQL Server client library for iOS and Android? And they'll say no, but we do have one for Windows Phone, for example, and you can write C# code. If you go to Oracle, what they'll do is they'll say, we have this Java connector technology that you can put on iOS and Android. It'll talk to the Oracle Fusion middleware on some machine somewhere, which can then talk to Oracle database and get data and give you back results and so on. So we realized years ago that we needed to provide to our customers a mechanism for not only directly connecting through to a remote database, that's our DB Express technology, now our FireDAC set of access components for doing queries and getting result sets back and doing things with them, having an in-memory data set that you could iterate through and do things with, manipulate and send the changes back. And in a disconnected, connected world, we also created DataSnap. So I have an application just to get us started that is sitting here. My environment here is I've got a Macintosh MacBook Pro. I'm running either Parallels Desktop 9 or VMware Fusion for the Mac 6. Right now I'm running Parallels Desktop 9, and I'm running, in this case, I'm running Windows 8. There's the little Windows 8 thing in the lower corner. I'm running Windows 8.0 as a guest operating system under Parallels. That way I can carry one machine for demo purposes versus what I have in the office where I've got a bunch of stuff. The IDE runs in Windows still. It's still a Win32 app. That's our IDE for C++ and Delphi. And we build our applications in here. It has a project group called Employee Directory. I've got a DataSnap server application written in VCL. And it's got a simple interface that starts and stops. And then it's got some server methods. Here's my FireDAC database connection, which is talking to interface. I've got some queries. I've got some master detail queries. Then I have the dataset providers that are sitting here. And I even have a web module because I might want to have a web client, a browser client, or some JavaScript HTML client that wants to connect to my DataSnap server. So I've got a proxy generator that's generating JavaScript REST code libraries for us automatically, so I can call the methods and get the data that I need if I'm building a browser kind of application or a browser container application. And so that's sitting there, and I've got it running. So I've hit compile and run, and it's sitting out there. It's listening for HTTP REST requests on port 8080. And I can even open a browser and say, well, if you have a browser, here's one of the remote methods. It's called reverse string. So if we key in something like hello Dallas, click this button, it makes a REST call from the JavaScript code into my DataSnap server running on Windows here, which is this thing down here, right? And then it calls a remote method that's in the public interface of my DataSnap server, where I pass it a string, it reverses the string and sends it back. We can look at the different server functions, administrative in the server method, and we can actually test them through this kind of mechanism. And down here we see the JSON. So DataSnap takes HTTP requests, it passes JSON method names and parameters, returns JSON, whether that JSON is a whole data set, a row set, or it's a simple value coming back. So there's our sort of browser interface. We've got a VCL and FireMonkey desktop interface, and then I've got these devices. And again, the mechanism is nice because it's one way of calling. You expose your interfaces, you connect to your data through the normal mechanisms, through these the data work controls. And then on a mobile device, all I have to do is make an HTTP REST call. We give you components for that. So let's look at the Macintosh or the iOS side. So what you're seeing here is my iPhone 4S showing up. We use a product called Reflector. It's $12.99, and it uses AirPlay to display what's on the screen here. So if I make changes, then you see if it's connected. Well, maybe it timed out. Where did that go? Okay. So let's check my internet. It's up there, but somehow my oh, I see. I'm not on my hotspot. So hold on. Let me just connect. It switched over to the restaurant Wi-Fi for some reason. All right. So now if I come back and I turn on AirPlay. Okay, hotspot there. Okay. So now it's really connected. So here's my, let's shut off this one and bring up the new one. Let's give me two, but here's my machine anyway. We'll put this over the top of that. So everything that I'm doing on my iPhone 4S is showing up on the screen. So here I've got an app, which is this connection app. And when I'm logged in to the IP on the login screen, it's talking to 192.168.43.34. That's my IP address that this app is running over here, and I can prove that by going and saying IP config. So here, 192.168.43.34, which is what my Macintosh my IO phone is connected to. And then I have different tabs set, tab items, and those tab items are connected to making a request of my DataSet server, which is going out to my SQL database and giving the employee information. So here's my list of employees, right? We put them in a list view. List view is one of the components we have, and it gives you that same iOS inertia and bounce. And you know, as you slide, if you slide a little bit, then it rolls a little bit. If you slide faster, so this is a component we've wrapped into the iOS look and feel called the list view component. You can use the list box component as well, which is a more complex component that we give you, where you can put all sorts of things in the list items, buttons, bitmaps, and all sorts of things. The idea here is that you have a simple item, and then if you hit these accessories, they're called, like the arrow, I hit on the arrow, it gives me information about a specific employee. I can use the back button, go choose another employee. I can step through the employee. And what's happening here is that, and it says what employees, with the one-to-many relationship, that employees working on multiple projects down at the bottom. We can go and look at those projects in the list view. What's happening is each time I do this, it's making a request through HTTP to the DataSnap server, which is doing something with the database to get the data back. Now you can cache the information locally. We have a thing called a client data set, so you can request as many rows as you want from the DataSnap server from the database, because you might live in a connected, disconnected world where I would disconnect from the database. I still want to be able to manipulate change orders of customers, make changes to employee information, and then once I'm connected back again, I call one method on a client data set called apply updates. It'll send a JSON packet back through of all the changes you've made to the DataSnap server. It will take that JSON and it will convert the values into a SQL update statement and send it off to the backend database. And all of that is done automatically for you by this provider. So this is the dataset provider for the projects table. Here's the dataset provider for the employee table. These are the two components that will take the row sets and will provide the data and metadata through the REST call to my client application. I didn't have to write any code. It's just components that I connect one property here to the query. So for the dataset provider gets its data set from the query. The query here for projects has a SQL statement that just says select P dot whatever, the full name from the project, left outer join employee ordered by project name for the employee to be passed to it. Right? So in that case, it's SQL statements, or I could call it store procedure. If you've got it all housed in a database in store procedure, then you put a tstored proc, tstored procedure component down, connect it to through the database connection. You get a pull down in the object inspector of all the stored procedures that are on that database. You can pick that one, and then you just pass the right parameters. So what we try to do is we try to do as much as possible in components. There is some code, that occasionally you write. For example, I needed to implement these two server methods, echo string and reverse string. So echo string takes a string and returns the result at the string we call it, and the reverse string just calls a built-in function, our string utilities code that takes the string that's passed as a parameter, calls reverse string, sends the result back. So here I'm just doing regular programming, and everything else has happened by the components, by wiring the components together. So we try to do that as much as possible. Again, you might want to build applications that that use the database locally on the device, and there we support SQLite, and we have our interface like IB Lite or Interface to Go, where you can put a full ANSYS SQL 92 interface server as a static library linked into your application. Same code running on Android, as long as this one didn't switch. So here's my login. Again, it's the same, 192.168.43. I'm logged in. There's the employees. I can go and look at the employee, see what's going on, go back. It's the same list view, so I can scroll around. This is watching through the debug interface, so it lags behind versus going through AirPlay. But it's still the same process. I can look at projects. I can see what employees might work on a certain project by clicking the staff button. We get the sliding that happens. We can go look at the different employees. We can go use the back button to go back, and I can hold it this way. So you'll see that the screen eventually catches up. The screen viewer catches up as well. Same project, just retargeted, recompiled for iOS and Android. Same component, same source code, same look and feel for the form design. So if we look at the mobile application, for example, here it's using the same database connection components down here. It's got the form. Here's the form with some tab controls and so on it. So again, same source code, just recompiled over here in the project manager by setting the target to 32-bit Windows, Android, iOS device, in my case, my iPhone, and the iOS simulator. So you spend your time building the user interface.